Welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and this is part 2 on the law of sines. In the previous video, I introduced law of sines. We know that when we're working with triangles, the sum of the angles has to equal 180 degrees. And here is the law of sines. The side A over the sine of angle A, the ratio of those two, will equal the ratio of side B to the sine of angle B, and that's also equal to the side C divided by the sine of angle C. There's a unique type of triangle that you may encounter, and I want to take a look at that. But basically, it's when you're given two sides of an oblique triangle, one of the sides is opposite an angle. So if, for example, we're given this angle, this side, and this side. If this side that's opposite the angle given is shorter than the other side, we have what's called an ambiguous case. It's a unique situation where there could be three outcomes. So I want to take a look at that situation. So I just outlined an ambiguous case will happen when you have two sides and an angle opposite one of the sides. So you're given, in this example, two sides and an angle opposite one of the given sides. The other condition is that the side opposite the given angle, so there's our given angle, here's the side opposite, it's shorter than the other side. If we have those two conditions, there's three possibilities for solution. The first possibility is that you're actually not working with an oblique triangle, you're working with a right triangle. And you may not know that it's a right triangle to begin with. So maybe you're given information like we are here, where this angle is 30 degrees, the side opposite is 5, and this side is 10. And we're going to go ahead and solve the way using the law of sines, and I will show you how you'll know it's a right triangle. So if we call this angle A, then this is side A, this is side B, this is angle B, this will be angle C, and side C. So we're going to start off plugging in the information we know. We're going to cross multiply. First of all, we're going to solve for sine B, and then we're going to find B. So we're going to get 5 times the sine of B equals 10 times the sine of 30 degrees. Then we're going to divide both sides by 5. And when we calculate this, we actually get a value equal to 1. To find B, you might recognize right away that what the angle is, but if not, if you go inverse sine of 1 on your calculator, you get an angle of 90 degrees. Because you have an angle of 90 degrees, you have a right triangle. So really the triangle won't look like that. It will actually form a right angle here. So I'm just going to redraw that. So now we've got 90 degrees. We can find angle C. Normally we use side C for the hypotenuse of a right triangle, and angle C would be our right angle. But because we didn't know that to begin with, we're just going to go ahead with the way I've named it here. And I'm just going to say angle C will be, if this is 90 degrees, then these two angles add up to 90 degrees. So therefore C is 60 degrees. And then maybe I'll just change this to a question mark, because with a right triangle, I don't like calling that side C. And I'm just going to get rid of that as B. So at this point, I could find this side, because it's a right triangle, I could use the right triangle theorem, or I could use a trig function. So my question mark squared plus 5 squared will equal 10 squared, just my right triangle theorem. So my question mark squared equals 75. I take the square root, and that side is 8.66. I'll just round it off to 8.7. So I was still asked to solve all of these missing values, but be aware that when you have a situation like I explained, and this side is shorter than that side, one possibility is that it could be a right triangle, and you'll know that if you get a 90-degree angle for angle B when you use your law of sines. The second scenario is as follows. So the second possibility is that if you got the situation where two sides are given and one of the sides is opposite the angle given, and that side is shorter than the other given side, there could be no triangle at all. Let me explain by trying to solve this oblique triangle using our law of sines. So we need to start with this side and this angle, and we're going to find angle B because we have the side B. So 6 divided by the sine of 50 degrees will equal 8 divided by the sine of B. We need to find sine of B. We're going to cross multiply. We're going to divide by 6 so we can isolate sine of B. The sine of B, when I calculate that, is 1.02. Right away, alarm bells are going off. Remember that the sine is the ratio of the opposite side to the hypotenuse. The hypotenuse is always the longest side in a right triangle. So it's impossible to get a sine greater than 1. And in fact, if you try this on your calculator, you will get error, because there's no angle whose sine is equal to 1.02 or anything greater than 1. So if this happens, if this situation happens, it means that it's impossible for this to be a triangle. It means this side is so short, this 6-unit length side, it actually won't touch this other side. So we have no triangle, therefore no solution. So when that happens, don't be alarmed. Just realize that the numbers don't work. It's impossible to have a triangle with those dimensions. Then there is a third possibility. Just to recap, if you're given an oblique triangle where you have two sides and an angle opposite one of the sides, if the side opposite the given angle is less than the other side given, you either have a right triangle, you have no triangle, or you actually will have two triangles, therefore two solutions. So if you do get an angle for angle B that's not 90 degrees and you don't get an error, then you know that this is the situation, and you're actually going to have to find both triangles. Most students miss the second triangle. They solve for the one triangle, not realizing that there's actually another triangle that fits these requirements as well. So let's find our first triangle. We plug in our values. We solve for sine B. So we cross multiply. Isolate sine of B by dividing by 7. We get a ratio of 0.875. So we find the angle by taking the inverse sine of 0.875. That gives us an angle of 61.1 degrees. So if this angle is 61.1 degrees, we can find angle C by taking 180 degrees and subtracting 50 degrees plus 61.1 degrees, which is 111.1 degrees. So C will be 68.9 degrees. Then we can use angle C to find side C. We plug in our values for side A and angle A. Side C is what we're finding. And angle C is 68.9 degrees. Multiply both sides by the sine of 68.9 degrees. And we get a length of 8.5. So we've solved one of the two triangles. And like I said, most people will stop there without realizing that there actually is another triangle. In order to find that other triangle, what you have to realize is that this side with a length of 7 could actually come in this way. So here's our other possible triangle. So that 7 could swing either way. And this becomes an isosceles triangle. So if this is 61.1 degrees, we know this is as well. So now we're trying to solve that other triangle. And in order to solve that other triangle, I can use the fact that this angle is 61.1 to find my new angle B in that smaller triangle. So I'll redraw the triangle. So what I've drawn is in the new triangle with solid lines, and that was my other triangle in the dotted lines. I'm really just interested in the fact in this other part here that this angle is 61.1. So I know a straight line, the total angle is 180 degrees. So to find angle B, I take 180 degrees and minus 61.1 degrees, which will give me 118.9 degrees. Would be the angle in my new triangle. So I'm just going to get rid of this now. This new angle B is 118.9 degrees. So in this triangle, that's angle B. In order to find angle C, I know A plus B plus C add up to 180 degrees. So C will equal 180 degrees minus 50 degrees plus 118.9 degrees. So C will be 11.1 degrees. Now that I have angle C, I can find side C, the missing side in this triangle. So side A is 7, angle A is 50 degrees. I'm finding side C, and angle C is 11.1 degrees. I multiply both sides by 11.1. I'm running out of room, so I'll just put the value. C ends up being equivalent to 1.8 units, side C. So those are my two solutions. So be aware that there are two possible answers in a very unique situation. We're going to look at more oblique triangles where we need more than the law of sines to solve them in our next video. So we're going to get into the law of cosines next. But practice the law of sines as much as you can. And then when you're ready, take a look at the next video. Take care, and we'll see you.